Okay, so we're going to talk about blood vessels. So if we were to draw a really simple diagram of the heart, with just representing the heart as a box. Clearly the heart is not a box, but we'll just represent it as one. And let's say, just say from this side of the heart, we've got our blood flowing out. And maybe that might be, say for example, from the aorta. So this here is an artery. And what is going to happen is blood is going to flow through this artery, and then it is going to branch off into different, slightly smaller arterioles. So these here are slightly smaller branches, are our arterioles. And then from our arterioles, we're going to have blood enter smaller vessels, which are very thin. And these vessels are the ones that line the cells and tissue in the body. And these are our capillaries. And then the capillaries are going to filter into venules, which are a small type of vein. So then we have venules before the venules filtering back into larger veins, and those veins are going to return blood back to the heart. So this is going to be a vein. And an example of this might be this being the aorta, sending blood to the body, and then this here being the vena cava, or although it is the wrong way around, this might be the pulmonary artery, and this might represent the pulmonary vein, and here would be our alveolar sacs lining our capillary. Okay, so now what we need to do is talk about the structure of our arteries, capillary and veins. So starting with arteries, what we have is we have a reasonably thick layer of collagen on the outside of the artery. And the role of collagen is strength, so that the artery can withstand the high pressure. Then next layer, we're going to have smooth muscle. So drawing this round like so, this is our smooth muscle, and this is going to be needed for contraction, so for the arteries to be able to contract and squeeze. Then above this layer, you're going to have the next layer, which is going to be your elastic tissue, and that is going to allow for the arterial wall to stretch. And then finally, in the actual arterial inside the lumen, which is the internal diameter, you're going to have your endothelium, which is just a single layer of cells, and that is going to be smooth, which is going to prevent friction. So if I was to draw this from a bird's eye view, so we can have a bit better look, if I do that over here, so I'm looking at it from a bird's eye view, I've got my lumen, followed by my elastic tissue, followed then by my muscular wall, my muscle, and then followed by my collagen. Okay, so let's see how this compares to the structure of a vein. So with a vein, I'm going to have, first of all, a noticeably larger lumen. So my lumen size is far larger, and this is my endothelium cells. That's our single cell of cells. Then I'm going to have an elastic tissue layer, which is not as large. And then again, smooth muscle layer, again not as thick. And then also my layer of collagen. So what I need to be thinking about is the reasons why these structures are different. So the artery is very much designed to be able to carry blood at high pressure. So that's why it's going to need to have that thick layer of collagen and muscle, as well as also a thick layer of elastic tissue to allow the walls to stretch. And veins are going to carry blood back to the heart in low pressure, so therefore they can have a thinner layer of elastic tissue and collagen, and they tend to have a wide lumen, which also contains valves. Then, if we were to talk about capillaries would be very, very small and only a single layer of flattened epithelial cells, endothelium cells. Okay, so if we were to have a look at this table, what we're going to try and do is pause the video and rank first to third for our various different columns. So lumen size or lumen diameter, artery, veins, capillaries, elastic wall thickness, muscular wall thickness, and pressure blood is carried out. So pause the video and just have a go at this. Okay, so our lumen diameter starts with veins, having the largest lumen diameter, followed by arteries and then capillaries, which are very, very narrow. Elastic wall thickness is arteries, followed by veins, and Na for capillaries, as they don't have elastic walls, they're only one cell thick. Same with the muscular wall, arteries, veins, followed by not applicable. And then pressure blood is carried out. We have arteries, veins, and then capillaries. So now if we have a look and try and place the appropriate statement next to the appropriate part of one of the blood vessels. And then once we've done that, have a go at making sure that we put this in order from starting at the heart to returning back to the heart. So you pause the video and have a go at that. So hopefully we can recall that the smooth endothelium cells, which are in the lumen of a blood vessel, prevents friction. Then we have our muscle wall or muscular wall of smooth muscle for contraction. Then we've got our elastic tissue, and we have our collagen. And then we have valves, which can be found in veins to prevent the backflow. Now, if we can recall, we start off with our endothelium cells, then we move into our elastic tissue, followed then by our collagen, by our smooth muscle. And then finally, we have our collagen. Then, so now starting with the heart, we're going to go to the arteries first, then the arterioles, then the capillaries, venules, and then the veins, which is the vena cava, before returning back to the heart. So I could have put aorta in here as the artery. So it is just worth noting when we talk about the capillaries being very thin layer of endothelial cells, we are talking 4 to 10 micrometers in diameter. Now to move on to the structure of the heart, which can be a bit tricky when looking at a more complicated drawing, such as the one we have on the screen at the moment. We have the right atrium, followed by the right ventricle, which then gets pumped up through my pulmonary artery, and this is going to be going to one side of the lungs and the other. So this here is my pulmonary artery, before then returning back to the heart into the left atrium, and that is going to be returning from this side of the lungs through here, and from this side of the lungs and on the back of the heart through here. So this is my pulmonary vein on either side, filtering into the left ventricle, atrium, then going through to the left ventricle before being pumped up through the heart to the aorta, which is going to go up to the top of the body through here, or down towards the bottom of the body down here. So this is my aorta, before returning back to the body via the vena cava, both the superior and the inferior vena cava, which is going to be the main vein. So here we have our atrioventricular valves on this side and this side here, and then we have located here and here our semilunar valves. So if we have a go starting in the right atrium and seeing if we can plot where blood goes to through various different labels we have here, all the way until it returns back to the right atrium. This includes some of our AV valves on the left-hand side, AV valves on the right-hand side, semilunar valves on the left-hand side, semilunar valves on the right-hand side. So we pause the video and give this a go. Okay, so we're starting the right atrium, then we're going to go through the AV valve on the right-hand side to the right ventricle. Then from the right ventricle, we're going to be going via the pulmonary artery. But before we do that, we're going to have to go through the semilunar valve on the right-hand side of the heart to the pulmonary artery, which is then going to go to the lungs before returning back to the left atrium, then going through the atrioventricular valves on the left to enter the left ventricle. From the left ventricle, going through the semilunar valves on the left to the aorta, which will then pump blood to the body before returning via the vena cava.